So students, we have seen the accelerations produced in the uniform circular motion and non-uniform circular motion. That is, whenever particle is performing uniform circular motion, the acceleration that we call it as a centripetal acceleration. And when the particle is performing non-uniform circular motion, then this centripetal acceleration is not alone, but the component of this acceleration which is lying along the tangent to the circle produces and gives rise the net resultant acceleration, which is the vector sum of the centripetal acceleration and the tangential acceleration that we have seen. Now see here, as the particle is performing uniform circular motion with certain acceleration, what does it mean? Means certain force must act on the particle which produces this acceleration. Continuously, a force must act on the particle which is responsible to keep the particle in a circular motion along the circular trajectory. And this force that we are going to discuss here. What is this force in UCM or non-UCM, or what is the magnitude of this force we will discuss today. So see here, up to this about acceleration we have seen, and we know that the force is nothing but the product of mass into acceleration. So which force is this which is responsible for the circular motion, right? Particle, the motion of the particle is along the circumference of the circle, say with radius r, m be the mass of the particle. Along the trajectory it is going to move. Then what will happen? At every instant of time, during the motion, a force acts on the particle which produces the acceleration. Previously we have seen that the centripetal acceleration is responsible for the particle to keep it in a circular motion. Elsewhere, suppose at any instant of time, suppose the particle, what happens? It will move along the skid of the circular trajectory. Then where does it move? It will move along the tangent to the circle. We know that at any instant, whenever it leaves the circular motion, it will move along the tangent to the circle, right? It means this is what the direction of linear velocity, and we have seen that always this linear velocity and radius vector, and ultimately as we have seen centripetal acceleration which is along the radius and towards the center, thereby the force which we call it as a centripetal force. The word centripetal means it is lying along the radius and towards the center. It is directed towards the center. Force that is product of mass into acceleration, and thereby mass into which acceleration? Nothing but the centripetal acceleration. Centripetal say acceleration. So centripetal acceleration, what is the magnitude of this centripetal acceleration we have seen? It is equal to minus into v square by r, or it is equal to m into minus, so it is equal to minus mv square by r, or minus mv omega, value of centripetal acceleration is minus v omega, or it is minus omega square r, so mass into minus omega square r. This is what the magnitude of the centripetal force which produces centripetal acceleration acting on the object at every instant of time during the circular motion to keep the circular trajectory, right? So in obviously this negative sign indicates that the centripetal acceleration is lying along the radius and towards the center. Different types of forces. See here, different types of forces in different types of circular motion acts as a centripetal force. Which this centripetal force is not a individual one like that. Say suppose we will consider the different examples of circular motion. Fine. Say earth or planet, earth or say any satellites, artificial satellites or earth, they are revolving, or planets revolving around the sun. During this circular motion, what is about the centripetal force which keeps the earth or planets continuously revolving in a particular orbit around the sun? So that force is nothing but the gravitational force. In this case, it is nothing but the gravitational force. So gravitational force acts as a centripetal force and keep the planets or earth in a circular orbit. Fine. Secondly, if we consider another example, say a stone tied to the string and reeled in a horizontal circle like this. Then in this case, suppose stone is here, it is tied to the string, the length of the string acts as a radius of the circle and reeled in horizontal circle. We found the tension in the string. Obviously what creates a tension acts on the string. Suppose this tension is loosened or the string gets slackened at any instant, obviously the stone will thrown off tangential to the circle, or it cannot complete the circular motion. It cannot complete a circular loop if the string gets slackened. Means what? Obviously the tension in the string released. So this tension which is acting like this radially along the radius and towards the center. So in such an examples, the force tension in the string acts as a centripetal force. Acts as a centripetal force to perform the horizontal circle. Say another example we will consider. Suppose a car is negotiating a curve. Suppose a car is moving along a track, say of radius r. Then what will happen? For this negotiation, without skidding off or without moving along the tangent to this circular path, which type of force here? Obviously nothing but the centripetal force. And which force acts as a centripetal force is nothing but the frictional force. It is frictional force which acts as a centripetal force to perform or to negotiate this curve by the vehicle, any vehicle, so any two-wheeler or anything like that. So this is negotiation is with the help of frictional force. Or say one more example, if we will consider here, the electrons are revolving around the nucleus. In this case, in a particular orbit without change in the orbital radius, then which force acts on the nucleus to keep them in a circular path is nothing but here the Coulomb's force on by the nucleus, that we call it as a simply nuclear force. So this nuclear force in this case acts as a centripetal. So likewise, different types of forces which are responsible in case of a particle which is performing a circular motion acts as a centripetal force and are performing the complete circle. Which type of forces are this? See here, if we see here, the gravitational force or say frictional force, nothing but we can say electromagnetic force or nuclear force. These forces tension or frictional force, electromagnetic forces. So these forces are nothing but, we have seen in our aerial standard, we have studied about this, that is the real forces. These are nothing but the real forces. So real forces, which force we are said to be, which are said to be the real forces, that is whose in those the forces which arises due to the known interaction, whose origin is known, such forces we call it as a real forces. So due to the interaction of the real forces or known forces whose origin is known, due to such forces which acts as a centripetal force in case of a different types of circular motion are responsible to keep the body in a circular path, producing an acceleration which is nothing but the centripetal acceleration, which is always lying along the radius and towards the center. Thereby we call it as a centripetal force. So wherever there is a circular motion, obviously an object is acted upon by the centripetal force, and whose direction is almost obviously along the centripetal acceleration, that is along the radius and towards the center. Now from this we can have one more conclusion. Say suppose at any instant of time, what is the work done by this force? Right? We know that work done is the product of force into displacement. That whenever a force is applied to a body and the body can displace, then work is said to be done. Then what is about the work done in case of uniform circular motion? In this case, the net work done is nothing but, how it could be? It is 0. Why it is 0? Work done by centripetal force is 0. Because work done is the product of force into displacement, that is F. Yes, actually it is the scalar product F S cos theta, or we can say work done scalar product of vector F dot vector, F dot vector S, that is F S cos of theta. Means theta is the angle between force and the displacement vector. So in case of a circular motion, if we observe the direction of this centripetal force is lying along the radius towards the center, and the direction of displacement or say linear velocity, it is perpendicular to this. It means the angle theta between them is 90 degrees. So cos 90 is 0, and we found that net work done by the centripetal force must be 0. So at any instant we can count it. If the particle may perform half circle or anything like that circular path, then at this instant this is what the direction of force and direction of what? Displacement. There again it is perpendicular to each other, and we found that the net work done by the centripetal force is equal to 0. So it is in the inertial frame of reference. It is real force, and the it obeys Newton's laws of motion. Right? Now the another force which is exactly opposite to that of this centripetal force, opposite in the sense opposite to that of, opposite means the direction of this force is opposite to means centripetal force, that we call it as a centrifugal force. Now see what is about the centrifugal force. Centrifugal means along the it is along the again radius, but not directed towards the center. It is fleeing off, that is away from the center. Its direction is opposite to that of center. See, this is what the direction of centripetal force. Then the direction of centrifugal force is like this. exactly opposite to that of a centripetal force along the radius but away from the center. Such a force is called as centrifugal force. So as the centripetal force is acting on the body, thus the centrifugal force is also acting at every instant of the particle or object performing circular motion. Is it happen? Does it have? We will see first of all certain examples regarding to the centrifugal force and then find out the magnitude. Fine. As we have seen the examples of centripetal force which acts as a centripetal force with different forces which acts as a centripetal force for the circular motion. Then what is about the centrifugal force at the same instant? If we see, for example, merry-go-round. If we are sitting in a chair of merry-go-round, you have ever sit in a merry-go-round, so you have experienced this. So when the merry-go-round is moving or performing this circular path along a fixed axis, what will happen? We feel that we are pushed in the radially outward direction. When the velocity, which one? That is angular velocity. This is what a pole and for the circular motion about which it is performing. So if we observe this, we are pushed radially outward at each and every instant during this circular path. The passengers sitting are in these merry-go-round chairs or horses, anything like that, they feel an outward force acting on them. So does there any force acts like this? Is it a real force? Actually, according to the Newton's first law, we know that unless and until an external unbalanced force acts on a body, the body will not change its state, either in a state of rest or of uniform motion. But we found that a force acts which is not directly acting on the particle, actually it is performing the circular motion, means centripetal force must be there. But at the same time, we found that we are pushed radially outward. Or say one more example, if we consider as, say suppose a car is moving along a circular track, and while negotiating the curve, the passenger in the car is pushed radially outward. It means here also, do we find any force is directly acting on the passenger? No. He is inside the car. Is there any force directly acting? We don't found any force which is directly acting on the particle or there is direct interaction. But still the output we found is that the particle is pushed radially outward. Fine. So it means that there must be certain force which is acting on the particle in the non-inertial frame of reference. If we found in the inertial frame of reference, for example, so suppose we are standing on a turntable. Turntable is rotating. For we people, suppose we close our eyes, we found that we are at rest, right? But actually the observer which is outside, we found that you are moving along with the turntable with an increasing angular velocity. What does it mean? In the inertial and non-inertial frame of reference, it differs. Actually, this force does not arise due to the non-interaction, means it is not a real force, because this force, such type of force, certain force must act on the body so that the body or the object or the said passenger in any of this case is pushed radially outward in the circular motion. Means certain force must act on the object. But which force is this? This is not a real force because it do not arises due to any of these force, not the gravitational force, not the electromagnetic force, or not the nuclear force like this. Thereby, this force we must call it as a pseudo force or an imaginary force or say fictitious force. So the force must be there. If we record this force, suppose the during this circular motion in case of a merry-go-round, the chairs or these objects, they are not moving with uniform motion until they reaches to the uniform motion. During this accelerated motion, if this force is recorded, then this force is it is greater than that of the magnitude of the centripetal force. Means during, if we record it, it is found to be greater when the circular path or the object reaches to the uniform motion. We found that the magnitude of this centrifugal force, which is nothing but the force acting on the object which is lying along the radius and directed away from the center, such a force is having magnitude equal to that of the magnitude of the centripetal force, which we have found, and the directions are opposite. It means the magnitude of this centrifugal force is equal to mass into acceleration, obviously mv square by r or mr omega square, or it is mv omega. This is what the magnitude of centrifugal force. What is about the magnitude of centripetal force? Is that minus mv square by r or actually magnitudes are same, but we write the centripetal force as negative sign here because the direction is along the radius and towards the center, whereas centrifugal force is along the radius but away from the center, and thereby in vector notation we found if the magnitudes are equal, but with vector notation they are exactly opposite to that of each other. So such a force, centrifugal force, which is nothing but a pseudo force, or it is in the accelerated frame of reference. It is in the accelerated frame of reference, or we can say non-inertial frame of reference. So you have an idea. If one more example of this centrifugal force we can give here as a rotation of the earth. As the earth rotates about itself along a fixed axis, then during this rotation, when the objects on the pole moves towards the equator, they feel a centrifugal force which pushes the bodies radially outward, and due to the continuous such type of circular motion of the earth around itself along the axis, we found that the shape of the earth is continuous motion, axial motion. Due to this, the shape of the earth is bulgy at the equator and flattened at the pole. That is what nothing but the earth we found as an elliptical shape, such that it is bulgy at the equator, because at the equator the centrifugal force acts on the earth, on the particles, and thereby its shape goes on increasing. The radius at this equator is greater than that of along the pole. So this is a most important example of the centrifugal force acting on the earth due to its circular motion, but this pseudo force which is acting along the radius and away from the center. So I think you have an idea about these two forces while a particle is performing centripetal and centrifugal force. In day-to-day life also we have an example of mixture grinder in which whenever the particle or the object which is kept inside the grinder, it will move radially outward when the grinder turn on. Or the washing machine, clothes in the washing machine, a dryer, the clothes get dried due to the centrifugal force acts on the clothes. How? When the dryer is moving with a continuously increasing angular velocity, the clothes are moved radially outward due to this pseudo force, say centrifugal force, and thereby they will move radially outward, and the water inside the clothes, it will move through the porous part of this cylinder of the dryer and the clothes get dried. So these are the applications of this centrifugal force. This is how we can differentiate between the centripetal force and the centrifugal force acting on the particle performing circular motion. If we see in terms of the differentiation, we can see here centripetal force, it's a real force. Centrifugal force, it is a pseudo force. Centripetal force, it is in the inertial frame of reference, and so it is a non-accelerated frame. Inertial frame, thereby non-inertial frame of reference, and centrifugal force is a obviously accelerated frame of reference. We can write here first of all, that is centripetal force is a real force because it arises due to the known interaction. Likewise, gravitational force or electromagnetic forces or nuclear force, whereas centrifugal force is a pseudo force. Secondly, this centripetal force is always along the radius and towards the center, means its direction is towards the center. Centrifugal force is also along the radius of the circle but away from the center. It is acting away from center. Then centripetal force, it is in the inertial frame of reference. Inertial frame of reference, and centrifugal force is in the non-inertial frame of reference. When say non-inertial frame of reference, it is nothing but an accelerated frame of reference, and inertial frame of reference is nothing but non-accelerated frame of reference. We have seen what is a frame of reference is. It is a standard reference. Inertial frame is nothing but the frame of reference which is at rest or moving with uniform velocity. Such a frame of reference we call it as inertial frame of reference, in which Newton's laws of motion are obeyed. So here for the centripetal force acting on the body, Newton's laws of motion are obeyed, but in case of a non-inertial frame of reference, which is nothing but a frame of reference which is moving with an acceleration with respect to the inertial frame of reference, then it is called as an accelerated frame of reference. So actually, and in terms of magnitude, the magnitudes of both centripetal and centrifugal forces are equal, that we have seen here. This is how we can differentiate between the centripetal and centrifugal force, due to which a particle is performing circular motion.